Hello, everyone. I wanted to make a quick video for you about the bisection method from section 2.8. Um, so we won't test you over the bisection method. It's not in your homework, but I wanted to go through it because especially if you're a computer science major, this is one of the first things that you may need to program. And so understanding how the process works will help you before you go in there so you can program it. You have to understand the process before you can program it. Okay, so in class we talked about how to use the intermediate value theorem to find out whether a function was guaranteed a solution in a certain interval, right? So we had to check two boxes. If your function is continuous on the closed interval, and if your solution is between f of a and f of b, right, between the y values at your endpoints, then we're guaranteed a solution. Now, in class and in your homework, we did not have to actually find the zero. We just had to decide whether or not we were guaranteed one. So if we're guaranteed one, how would we go about finding it? Most of the time, if we are going through the process of figuring out if we have a solution, they aren't going to be easy to find. Otherwise, if they were easy to find, we would say, oh, duh, we have a solution. So these are not usually going to be pretty numbers to work with. So the way the bisection method works is that we have to find two x values, x1 and x2, such that one has a positive y value and the other has a negative y value. So again, we're looking for where y equals 0. So if I have one positive y value and one negative y value, those are going to be f of a and f of b. So if one's positive and one's negative, 0 is going to be in there. So then in order to start figuring out what our y value is, we are going to take those two x values, x1 and x2, these are the x values at our endpoints, and we are going to find the midpoint. The way that you do that is you just average those a and b values. So you're going to take whatever your first x value is, your a, or x1 here is what we're calling it, plus your b value, or here we're calling it x2, and dividing by 2. This is going to be your midpoint. And then we are going to find the y value of that midpoint. We're just f of x sub m, whatever we get out of this, we're going to plug it into our function and figure out whether that y value is positive or negative. And then once we know whether that y value is positive or negative there, we are going to kind of split our interval into two pieces and figure out which one contains the 0. The way that we're going to do that is look at the signs at x1 and xm and the signs at xm and x2. Whichever one has the y values that switch signs, that's going to be the one that contains our 0. And then once we have that, we are basically going to take whichever of these, let's say it's in the second half, then we'll take that one, we'll rename that our x1 and our x2, and then again, we'll find the midpoint, we'll find the y value at the midpoint, and then we'll continue to kind of whittle our intervals down until we get super close to our 0. Okay, so let's try this. F of x equals 2 to the x minus x to the third. This has a 0 on the interval from 1 to 1.5. And we'll get into that in just a second. I want to perform 3 rounds of the bisection method to start to find a 0. Okay, so first of all, I'm going to find, so this will be my x1 and this will be my x2. So first of all, I'm going to find f of x1, which is f of 1. So I'm going to plug it into my function here. And I'm going to get 2 to the first minus 1 to the third. 2 minus 1 is 1. And I'm going to plug in my f of x2. So I'm going to do f of 1.5. And we're going to get 2 to the 1.5 minus 1.5 to the third. And I'm going to put that in my handy dandy TI30X2S. And it says I'm going to get negative 0.55. Okay, so notice that our function f of x is continuous because 2 to the x is exponential, so it's continuous everywhere. X to the third is a polynomial, it's continuous everywhere. So this entire function is continuous everywhere, therefore it's continuous on our closed interval. And I have one endpoint that's positive, one endpoint that has a positive y value, and the other endpoint has a negative y value. That means 0 has to be in here somewhere. So we are going to start our bisection method by finding the midpoint. So again, we're calling that x sub m. We're going to find that by x1 plus x2 divided by 2. So my x1 is 1, my x2 is 1.5. We're going to divide that by 2, and I'm going to get 1.25. Okay, now I'm going to figure out what the y value at my midpoint is. F of 1.25. So again, I'm going to plug that into my function. And my TI30X2S tells me that I get 0.425. So now the question is, where is my 0 now? It's either going to be in my x1, which is 1, to my midpoint, which is 1.25, or it's going to be in the 1.25, my midpoint, to the end, which is 1.5. Now, which of these intervals is going to be the one that contains my, my 0? Well, to do that, we're going to look at the y values. Notice the y value at 1 was 1. It was positive. My y value at 1.25, which is my midpoint, was 0.425, which is also positive. Because I don't switch signs, my 0 is not in there, right? If I go from positive to positive, I'm not guaranteed that there's a 0 in there. So let's look at 1.25 to 1.5. Again, at 1.25, our y value is positive, and at 1.5, our y value was negative. This is where our 0 is. And so basically, now I'm going to start over and do the bisection method again using that interval instead. So this was all round 1 because it said it wanted to do 3 rounds of the bisection method. So this is round 1. So now we'll move to round 2. And so we'll kind of rename this. So my x1 will be 1.25 and my x2 will be 1.5. And I guess we already have those up here. I'm just going to remind myself so that I don't get confused. And f of 1.5 is negative 0.55. Okay, and then I am going to find the midpoint by averaging my endpoints. And when I average those, I'm going to get 1.375. That's my midpoint. And I'm going to plug 1.375 into my function to figure out my y value is. I'm going to plug it in, put it in my TI30X2S calculator, and I'm going to get negative 0.0059. So again, now I have to figure out where my 0 is. So is it in 1.25 to 1.375, or is it in 1.375 to 1.5? Again, we are going to look at our y values and whether they are positive or negative. At 1.25, my y is positive. At 1.375, my y value is negative. I switch signs, so here is where my 0 is. Just to make sure, if you wanted to make sure it wasn't on the other side, 1.375 is negative and 1.5 is also negative. That doesn't switch, so definitely no 0 in there. Okay, that's round 2. And now we can move on to round 3. And again, I'm just going to remind myself what I am working with. We're going from 1.25 to 1.375. My y value at 1.25 was 0.425, and my y value at 1.375 was negative 0.0059. So again, I'm going to find the midpoint by doing 1.25 plus 1.375 divided by 2, and I'm going to get 1.3125. And now I'm going to put that into my function. And when I do that, I'm going to get 0.223. And I'm not writing out exactly how I did it. I plugged it into this function. So I did the 2 to the 1.3125 minus 1.3125 to the third, and that's what I got. And so now, where is my 0? Is it in 1.25 to 1.3125? Or is it in the 1.3125 to 1.375? Oops. And again, we'll look at our y values. Here we were positive. Here we are positive, so it's not there. And again, this one was positive. The 1.375, we are negative. Here is where our 0 is. And notice how much smaller this is getting. I'm going to be in 1.3 something, right? So I already have this 0 accurate to 1 decimal place. We'll further and further be kind of shrinking that interval down until we know exactly where it is and we can get really, really close. So that's how the bisection method works. I hope that made sense, and that's going to help you with your computer science classes or other classes where this might pop up. I hope you have a lovely day, and I will see you next time.